Well, welcome everyone. Glad you're attending. I'm going to try to give you some information today about at least one approach to using satellite rainfall and estimating floods across the entire globe. This is work that I and my colleague Huan Wu at the University of Maryland have been doing, partly affiliated with NASA's GPM program, but also with support from NASA's Applied Sciences program. I'm going to be showing to you some examples in the recent past, and then also trying to show you some real-time information. We'll take a look at satellite rainfall around the globe today, last few days, and we'll take a look at where there are some floods going on. And when I do the flood part, when I go on the internet, I'll be using this flood website, flood.umd.edu. And if you want to try to follow on, but I'll be on the website myself, and it might be easier just to watch what I'm doing. So the first slide, slide 2, actually encompasses most of my talk. Is kind of an overview, or at least the next slide will. This slide emphasizes the satellite rainfall, and a lot of this is associated with what you're probably familiar with as the TRMM, the Tropical Rainfall Measuring Mission. And we use rainfall that comes from TRMM, that single satellite, but actually that satellite combined with information from a number of other satellites, about 9 other satellites, to put together. I just want to, this is the TRMM multi-satellite precipitation analysis, which is a combination using TRMM data to adjust the rain estimates from other polar orbiting microwave satellites. And it's really a precursor to a data product that's going to be associated with the GPM activity. And what it does right now, it produces maps like I'm showing as an example here, every 3 hours and at a 1/4 degree latitude, longitude resolution. And this is the basis for looking at extremely high rainfall events and the associated floods. We're also using information from numerical weather prediction output, because obviously the satellite, the real-time observations only go up to current data, and we use some of the numerical model information to move our flood estimates into the near future. This is this slide. This is the rainfall data, and the way the process works, we use the rainfall information, the multi-satellite rainfall information. Every 3 hours, we put it into what's called a land surface model, which essentially uses land surface conditions, soil moisture, soil type. We use the land surface model to calculate how much of the rainfall is available to go into the surface, and then also to flow downstream. And after we calculate how much water is available to flow downstream, we use a routing model, a very fine resolution or at a coarser resolution, and I'll come back to that, to move the water downstream. So now we have a way of calculating how much precipitation is hitting the surface, how much is going into the ground, how much is available to flow downstream. And we use models, including data from satellites that produce digital elevation models, to produce this. Now, what we do after that fact, then we essentially have at every grid point across the globe, we have a calculation of water depth. And based on previous calculations over about 17 years of data, at every location, every physical location, geographic location, we set a flood threshold, which is about at the 95 percentile. So we're looking at the extreme events kind of at the 5%. As a starting point to say, okay, there's something going on. So when you come onto the website, or the result of the calculation is something that looks like this global map here, which is a global flood detection. And you can see areas of green, and you can see, if you look very closely, some other colors. And if you take this area here in South Asia and blow that up, where there was a flood going on along the Indus River, this is a couple of years ago, you get an idea that you get some different colors that are representing different depths of water over that flood threshold. So now this is where you're saying basically the flooding is occurring. And you also have the ability then to look at time sequences of this kind of thing and pick a point, for example, and do the flood detection parameter, and you can see it as a function of time. So you can see with the way this is working, it's no floods are here, then the floods started early in August. You can see where they're peaking at this point and then coming back down. And you can also look at other fields of data. For example, stream flow, how much water is flowing down the river, in this case, the Indus River. And you can see it growing as a function of time during the summer monsoon season, and then hitting what is the predetermined stream flow flood threshold here, and then going higher than that. So this is the area of the flood. So by using the satellite data, satellite precipitation data, and the models, and the historic runs of the model system, we now can get a time sequence of, in this case, stream flow, and get an idea of where the floods are occurring. The next slide shows an example. This is from the Philippines from a few months ago, back in December, Typhoon Hagupit. And to give you an idea of the satellite precipitation, this is an instantaneous 1 3-hour shot of the typhoon before it hit the Philippine Islands, which you can see right in here. You can also do time averaging or totaling up of the precipitation. For example, this is a map of 7-day rain ending on the 10th of December. And you can see the very large precipitation amounts. You see the red areas here are over 300 millimeters, or over 6 inches. So you're having very heavy rainfall events. So when you look at the flooding areas, and here we're using the stream flow above that flood threshold for a sequence of 4 days, on the 6th of September, the day after this image was taken here, you can see estimates of where the flooding is occurring. The yellow areas are 500 cubic meters per second stream flow above the threshold in this island and here. And as you can see, the typhoon tended to move from the southeast to the northwest. As you go day after day, you can actually see the flooding move to the different part of the island. And if we look at the next slide, we can see a sort of blow up of that. And you can see, for example, this area in here. And then if I mark this one X here, I can do a time history of the stream flow at that point. And you can see where it's increasing, hitting a peak, in this case, the 7th of December, and then coming down. And I've marked the 8th of December here because then if you look at this other area on the 8th of December, and just mark this time here, you can see that the flooding occurred after 8th December in this part of the island. So you have a way of tracking the flooding, getting estimates, quantitative estimates of the value of the flooding or how intense it is, and able to see the time history. Now in the next slide, I'll show you a few other things. One of the things I didn't point out in an earlier slide was that all the calculations that I've shown you up to this point have been done at 12-kilometer resolution, about an eighth of a degree latitude, longitude resolution. Now this is pretty coarse, although we do have our rainfall information is fairly coarse, being at about that same spatial resolution and only every 3 hours. So we have difficulty with flash floods and things like that. But through the modeling approach we're using, we're able to do the stream flow actually at much higher resolution than the 12 kilometers. And this is an example of the stream flow over one of these islands in the Philippines at 1 kilometer resolution. And it's hard to see in here, but there's one yellow stream that is the largest amount, over 1,000 cubic meters per second. If we do a time history there, you can see the peak at 1 kilometer. And one of the things we're doing with the 1 kilometer calculations, we keep track of all the water and see how much flows out of the banks, and there's a lot of kind of tricky modeling. And we come up with an experimental product that still has a long way to really reach its potential, but gives you the idea of being able to actually map at high spatial resolution, in this case 1 kilometer, where we think the flooded areas are, and actually giving an estimate of the depth to these things. So like in this case, we actually see the main areas of flooding are along this river in here on this island of the Philippines. And you can see other areas. And this is very valuable because obviously, ultimately, this is what people are interested in, as to how big an area was covered, where that area is, how it's changing in a function of time. Now, everything we're doing is making calculations based on the satellite rainfall, but I think as we move forward and try to improve these things, this kind of information will become more and more valuable. I'm going to show you another example. This is over Malaysia also back in December. And here you can see the stream flow above the flood threshold map, and you get an idea of the variations. And you can also, this is a very heavy rain event, where this is a blow up of the 7-day rain ending on 7th of December, and there was over 1,100 millimeters of rainfall fell right in this area. And you can see the stream flow calculation as a function of time at this point down here. And here is actually just to show you an example where at the time we did this, this was the real time where the vertical dashed red line is. And we actually used other information, numerical weather prediction information from a global model to add on to that to actually get another peak in the rainfall here. But this allows us to extend the estimates we're making out to a few days. We go out to about 5 days right now to able to extrapolate our conditions. And just to follow up on this case is also is looking at this one area up here, again at the higher resolution, both down here in this area and up here to get the flooded areas using the high resolution information. All these images I'm showing are typical of what you can see on the website, which we'll get to in a minute. Now this is kind of an interesting one. This is the same case, but we're looking at a stream up here right near the Thai border with Malaysia, and there's a river up here where the flooding was going on. But now what we've looked at, since we have 17 years of the precipitation data, we run the model historically, and we're able to look at how the flood event we were seeing in December 2014, how it compared to the time history going all the way back to, in this case, 2002. And so you can see almost every year you have flooding events in this area because you have the monsoon systems coming through. But you can see that the one we had in December 2014, which is the one I was just showing you, is actually the largest by a significant amount in terms of stream flow in that river. So this allows us to also produce, give an event the historic context, at least for the long but still relatively short record that we have from the satellite precipitation. So with that kind of giving you a few examples, we're going to try to switch and go to this website, flood.umd.edu. And what we're going to see, the first screen that's going to come up is going to look like that. And Kristen is going to switch me. This is the global flood monitoring system that we've built, and you can read about it here. And there's a journal paper that references it, et cetera, if you're interested in more detail. What I'm going to show you is here, I'm going to take a step back here. I'm going to go to another field. And we're going to talk, first of all, about the rainfall. What you're looking at right now is the latest 3-hour image from the TRMM multi-satellite precipitation analysis. You can see we're here on 15 April, but we run about 6 hours behind time, or a little bit more, so we're looking at 09 GMT. And you can see the precipitation systems around the world. And actually over land today, it's fairly dry, as often happens when I give these kind of talks. You can get an idea, you can look at other rainfall amounts, and you can see me, hopefully you can see me clicking around on the thing. This is rainfall at 1 day And this is essentially doing a rainfall accumulation just over the last 24 hours, ending at the latest time we have, and you can start to see some features. I'm going to go to even a longer period, 3 days, here for a second, because I'm going to pick out an area. And you can see now, obviously, the rainfall amounts increase because we're looking at a longer period of time. And you can see down here in Argentina that there's an area of fairly high rainfall, with colors being in the yellow, which is over 100 millimeters, or over 4 inches. So we're going to focus on that a little bit. This is the flood detection intensity for the entire globe. And what you can see is, and if you look at here, the scale, the small floods, so to speak, are in green, and we set the threshold low so we can see something. And if you look down here in Argentina, you can see that there's different colors. And what we can do is zoom in, and I'm moving around, zooming in and clicking, moving the cursor around here. It's a little bit of a kludgy system, but it works fairly well. And now we're seeing an area, and I'm focused down here. And here you can see some areas that, in terms of the flood detection, have the brighter colors, or the over 100 here. I'm going to switch and just look briefly at the 3-day rainfall. And you can see, oops, I hit the one down. You can see areas here up in here, you can see areas of over 300 millimeters of rainfall estimated from the satellite. And you can see areas of over 150 millimeters down here. This is actually in the more recent days, in the last couple of days. One thing, of course, all our flood calculations are dependent on the accuracy of the satellite rainfall. And the satellite rainfall information is not perfect. And one of the things we're doing with this flood project is really to try to understand how we can improve the satellite precipitation information. The other thing about our modeling system, it does not include any information about dams or artificial structures. So essentially, we're looking at flood estimates in a natural world. And we are going to be making some modifications to improve that, but there are those kind of limitations. So here we have an area, we've obviously had significant rain. We can go back and look at that flood detection parameter, depth above that threshold, and you can see it here. You can also do another stream flow above the threshold, and this is another way of looking at a very similar thing. And we can go in to zooming in a little bit here, trying to, so I can put my cursor on something here. And let's see if I can. And so here now we have an estimate. This is the stream flow above that flood threshold that's set for every grid box across the globe. And so you can see, according to this, the flood started at 12 GMT yesterday, and it is peaking here on the 15th. And one of the things we can do is we can actually extend this graph out into the future by changing the date. Hit the backspace here and hit And now what we have is here we are on the 15th, and I'm able to make a hydrologic calculation in real time of what the stream flow would be, the stream flow above the flood threshold, and extend it out in time, indicating that it looks like the peak of the flood is going to be right about at the present time, and then things should be decreasing, but there still will be some flooding there. And then go back to the map, and I'm going to zoom even in a little further and show you some of the high resolution things. And I'm going to show you the stream flow at 1 kilometer resolution. And now you can see that it looks very different from the 12 kilometer resolution map I was showing you. It's a little hard to see. The yellow is the highest values here, the main stem over 1,000 cubic meters per second. but you get an idea of what the stream flow pattern looks like. Again, the colors are related to the magnitude of the stream flow. You can go back and forth, and you can go back in time. You can step back in time, and you can actually see, for example, in this area here, you can see that the yellow boundary with the high values as you go further in future is going downstream. You can blow this up and put the cursor on and also see the stream flow. But now we can make a real-time estimate of actual inundation mapping for this area, and this gives our calculation of where we think the flooded areas are, again with the limitations I already mentioned. So what you have is the gray is the background area. The white areas that's not colored in are actually the stream locations, the river locations. And then you're seeing oftentimes along the edges of the river where we're calculating the water is standing above the flood threshold to the depth given here. And the blue areas are like a meter depth here. So, and these other areas, these light green areas, that's really not going to be serious in most cases. But you get an idea, and so you can do a time sequence there. Also, you can go back in time and see how things are changing or move up in time. Oops. I can go back to the actual stream flow at 12 kilometers, and you see something that's very coarse, but this is actually useful in a sense. I'm trying to zoom out here and take a much bigger view of the area, and you get a really good picture of the overall where the rivers are, etc. You can take one of the major rivers. I'm blowing this up. It's definitely a major river here. See if I get my cursor in the right location. And this allows me to do something, for example, to even go back just to the beginning of April and getting the time history of the stream flow. So now we have all kinds of things, being able to look at floods, being able to look at stream flow as a function of time, a number of things like this. I'm going to switch back to the slides here for a second and finish up, and then I'll be glad to take questions. So here's, this is the website I've been using, and all the images I've shown you, the kinds of things I've been able to do on the screen, you can do yourself if you're interested. We'd certainly be able to try to answer any questions you have. Our website is actually accessed by a number of groups and organizations around the world. There's a significant amount of interest in international relief agencies who are trying to monitor floods on a global basis. For example, the World Food Program in Rome uses it, International Red Cross. There are also national agencies in the U.S. who are interested in monitoring global floods. And there are organizations across the world, even in developing countries, who are accessing the data to try to use things. So with that, what I'd like to close any kind of formal presentation at this point, and I'd be glad to try to answer any questions you might have. Thank you.